Greetings, my name is Brendan Kersey, and today I'll be going over some of the stuff that I learned from the making a beam emitter effect tutorial. So without further ado, let's get into this. So starting off, I'm going to kind of go over the material itself that needs to be set up first, how to create our sort of initial beam itself. It's pretty standard and straightforward. You start off here with your with a nice particle color that's thrown in. Will be for controlling the actual color of the beam itself later on in Cascade. Pretty straightforward. This chain down here is what actually creates our beam itself, so to speak. So it's a pretty straightforward process. You simply take a texture coordinate, you mask it, and you only leave the green channel because that's what will give us our nice little gradient. I divided the gradient in half in order to kind of even out the scale from the masking. The next portion is to use sine. The reason that we use sine is so that way we can go from the values of -1 to 1. And this is what gives us our nice dark to white and white back to dark gradients. The next bit here is kind of a power of 3. The reason that we use power is to kind of control necessarily like how much of the shadow border is on both the top and bottom spectrum. So like say for instance, I know it may be a little hard to see right here. Zoom in. Well, I guess as far as I can zoom in. But to give you kind of an example here, right now it's set to 3, but if I were to increase it even further, like say to about 10, good moment. All right, good. You'll notice that our kind of white space area has kind of narrowed, and that our more darker space on both sides is kind of widened. This is kind of meant to control like the sort of the brightness of the center of the beam itself. So that's kind of why we use power here. And then obviously, as I'm setting this back to normal, I kind of zoom out here. So we bring it back forward, multiply it with the particle color in order to get our kind of our miss of a color, and then take the alpha for our particle color, multiply it by our texture coordinate to get our opacity. One last thing you will want to do is you will want to change the blend mode to translucent and then the shading model to unlit. This is just for mostly for beautification purposes. That way it looks nice and clean. So that's pretty much all of our material. Now let's move on to the particle effect itself. So with this, it's pretty straightforward to set up. All you need to do is just simply add a type data, in which we add our beam data. Now, it's pretty straightforward. Simply allows us to, you know, obviously change your material to the beam material that was mentioned earlier. Is one other important step. So with beam data, all you really need to do is increase the number of sheets to render, just to keep it kind of nice. So the next main point in setting this up is I'm going to talk about how we make this curve right here. And there's a couple steps to that. First is you need your number of interpolation points. The reason that we have interpolation points is that so that way we can draw a nice kind of like tangent line. And this is something that we set up in two separate modules known as our source and our target. Our source kind of controls our left side of the arc, for instance. So as you see here, I have two separate parts that are important in this, our distribution and then our source tangent. So our initial source distribution just kind of defines how long the particle effect is itself, or the beam, so to speak. So it's about a standard 200 units in the XYZ coordinates. Stranded along the X, there was no reason for me to raise it up or down with our Y and Z. Same goes for here in our targets. This one is a positive 200. So I'll give you kind of an example. Say I change to, I don't know, -20. You'll see that our left side kind of fades in back, or trying to move right towards the center. Whereas if I did, give me one to correct that. Whereas if I did it with our target, change that to a 20, our right side would be going more towards the left, towards the central origin. So that generally controls our beam length. The next few things to do go with this is kind of making our arc itself. Now this is kind of where our initial interpolation points kind of blend in with source and target. For these, you kind of want to help define the tangent for the curve for both source and targets. Generally with source, we go positive, so that way we can start from Obviously you imagine a flat line here, that's our 0. So 40 degrees upward. That kind of initiates our initial left arc. And then with target, you kind of want to do -40 because you want to kind of like bring it back down, so to speak. So that's kind of how like we draw our arc. I'll give you a quick brief demonstration. So say I change this back to go to our Z. Z kind of controls our up and down, so to speak. So I do 20. See our arc on our source on the left side kind of it's still a nice little arc, but it's not quite as high anymore, so to speak. Um, back. So same goes for our target. If I were to change this to -5, it's probably going to get real. All right, it's a much more sharper, a little bit more linear drop, but that's fine. Um, but yeah, that's just a brief little demonstration of the draw the curve itself. The other important bit is you definitely want to have a nice number of our interpolation points. Reason being is because you want that nice smooth curve. I were to drop it down to say 2, let's see, we've drawn a triangle, which is not necessarily what we were going for here, going for a nice arc. So definitely want to find a balance with our interpolation points in order to draw a nice curve. In my case, I used about 20. I felt that was a nice, neat, smooth curve. Can also increase this as well. But it doesn't really make too much of a difference. Yeah, so let's get that back to normal. All right. So the last little bit in making this is kind of like the staticky vibrational effect. So as you see, our different beams are kind of juddering and kind of like a plasma ball effect that you may have seen like at a museum or something, and that is created using our what it's called our noise module. And in our noise module, we generally set this to kind of like a uniform so we can have a range, like a nice min and max with Y and Z to create our little kind of bouncing effect. Set to a nice 30 difference. Kind of felt like that was pretty good. Yeah, so pretty much it. As you can see, the final result is our particle effect here. There's a lot more stuff you can also do with this. From what I've learned, you can actually change this to particle parameter. And from there, you can kind of mess with using blueprints and various things like that in order to kind of manipulate our little noise or particle effect, I should say here. Kind of readjust this back. But yeah, after doing this, clearing out seed, now it's just one standard arc, not really moving. But once I start typing in, these variables manipulating on Y, now you're seeing it's beginning to shake. So give it just a little bit more. Now, obviously, as you increase the range between them, it'll obviously grow in intensity. So that's pretty much how you set up this particle effect. So that concludes the video. Thank you for watching, and if you're interested, feel free to contact me either via my email or my blog, which will be posted in the link below. Thank you. Goodbye.